Let us discuss about binary symmetric channel BSC. First of all, channel diagram of BSC. For a binary source, we have two symbols x1 and x2. x1 is encoded as 0 and x2 is encoded as 1. When x1 is transmitted, there are two possibilities at the receiver as y1 of 0 and y2 1. If 0 is transmitted, 0 received, that is this path, correct transmission with probability P bar. And 0 is transmitted, 1 received, that means incorrect transmission with probability P. We know that total probability is equal to 1, that is P bar plus P is equal to 1. From that, P bar is equal to 1 minus P. Then, when 1 is transmitted at the transmitter side, then there is two possibilities. We will get either 0 or 1 at the receiver side. When 1 is transmitted, 0 is received, that is incorrect. That is, it is with the probability of error P. When 1 is transmitted and 1 is received, there is correct transmission with probability P bar, that is also equal to 1 minus P as here. This is the channel diagram of the BSC. Next is the channel matrix. Channel matrix P of y given x is equal to, it connects x1, y1, x1, y2, x2, y1 and x2, y2. That means P of y given x, P of y1 given x1, first entry. P of y1 given x1, y1 given x1, that is with probability P bar. So, first element is P bar in this matrix. Then next is P of y2 given x1. y2 given x1 is with probability P. So, here it is P. Next is P of y1 given x2. P of y1 given x2 is with probability P. So, here P. Next is P of y2 given x2. P of y2 given x2 with probability P bar. So, P bar here. This is the channel matrix of the binary symmetric channel. Next, let us discuss about channel capacity of binary symmetric channel 1 minus h. We know that channel capacity C is the maximum of the mutual information I of x comma y, where I of x comma y is equal to what? H of y minus h of y given x. Let it be the first equation. We know that P of y given x is equal to P bar P, P, P bar. Also, this matrix is a symmetric matrix, that is, BSC is an example of symmetric channel. For symmetric channel, h of y given x is equal to sigma j equal to 1 to 2 pj log 1 by pj. Here, pj means p1 and p2. Here the probabilities are P bar and P. So, we can write h of y given x or equivocation of this symmetric channel is equal to P bar log 1 by P bar plus P log 1 by P, that is equal to h. Let it be h, and it is noted as second equation. Next, we want to find out h of y for getting mutual information. We know that as per Bayes' theorem, P of x comma y is equal to P of y given x into P of x. We have P of y given x channel matrix as P bar P, P, P bar, and let probability of x1, that is first symbol, is equal to w, and probability of x2 is equal to w bar. Then, for getting P of x comma y as per Bayes' theorem, let us check the matrix of P of y given x and this probability, and we will get P of y1 given x1 into P of x1, that is P bar into P of x1 is w, P bar into w. Here, P of y2 given x1 into P of x1, that is P into w, that is pw. Similarly, the second row, which corresponds to the source symbol x2, P of y1 given x2 into P of x2, that is P into w bar, that is P into w bar. the last element P of y2 given x2 into P of x2. P of y2 given x2 is P bar here, P bar into W bar, that is P bar into W bar. Thus we get the joint probability matrix for the binary symmetric channel. We know that the first column sum will give P of y1. So P bar W plus P W bar is equal to P of y1. And the second column sum will give P of y2. So P of y2 is equal to PW plus P bar W bar. Using these two equations, we will get the entropy of the y, that is h of y. As per the equation, h of y is equal to what? H of y is sigma j equal to 1 to 2 P of y. H of y is equal to sigma I equal to 1 to 2 P of ya log P of ya, that is equal to P of y1 log 1 by P of y1 plus P of y2 log 1 by P of y2. We get the P of y1 as P bar W plus P W bar and P of y2 as P W plus P bar W bar. Substituting this, we will get h of y is equal to P bar W plus P W bar log of 1 by P bar W plus P W bar plus P of y2 is P W plus P bar W bar log of 1 by P W plus P bar W. Then when the source emits a symbol as a equiprobable events, W is equal to W bar is equal to half. Put this value in the above equation. Then h of y is equal to P bar into half plus P into half log of 1 by P bar into half plus P into half. That is substituted W is equal to half and W bar is equal to half. Then plus P into half plus P bar half log 1 by P into half plus P bar into half. Half is common here. Let it be outside. 1 by 2 into P bar plus P log of 1 by half of, half common here, half of P plus P bar. Half is common here, half of P plus P bar log 1 by half of P plus P bar. What is P plus P bar? It is the total probability, that is equal to 1. So half into 1 log of 1 by half into 1 plus half into 1 log of 1 by half into 1. That is half log 2 plus half log 2. What is log 2? To the base 2, 1. That is half into 1 plus half into 1. That is half plus half equal to 1. Here we get h of y is equal to 1 only when W is equal to W bar is equal to half. Then what will be the equation for I of x comma y? I of x comma y is equal to h of y minus h of y given x. Substitute 2 and 3 in our first equation. We will get c is equal to h of y minus h of y given x. H of y is 1. H of y given x is h. That is 1 minus h. Or h is equal to what? P log 1 by p plus p bar log 1 by p bar. Or c is equal to 1 minus p. 1 minus of p log 1 by p plus p bar log 1 by p bar. Also, for a symmetric channel with R is equal to 1 message symbol per second, C is equal to log S minus H, where S is the number of source symbols, that is log 2 minus H, that is 1 minus H. Both equations 4 and 5 are same. That is, when the input symbols are equiprobable, the mutual information maximizes and becomes equal to channel capacity. Again, BSC binary, for the binary symmetric channel, channel capacity C is equal to 1 minus H, where H is equal to P log 1 by P plus P bar log 1 by P bar.